In this video, I'm going to explain the concept of thermal equilibrium for the new Year 11 course. So two bodies are said to be in thermal equilibrium if they're at the same temperature. This means there is no exchange of heat energy between them. If there is an energy flow between the two objects, then they are not in thermal equilibrium, and you can see that in the diagrams there. So heat will always go from the hotter object to the cooler object. Okay, you can see that in the red and the blue diagram. But if they're in thermal equilibrium, the energy is the same, so they just interplay with one another. Okay, whereas the red goes to the B because it's cooler. Okay, so heat always goes from the hot object to the cooler object. And this leads us to the next two laws of thermodynamics. So the 0th law of thermodynamics is if two bodies are in equilibrium with a third body, then they are also in thermal equilibrium with each other. Further, if two bodies are in equilibrium, then there are no detectable flow of heat energy from one to another. The first law of thermodynamics is basically the law of conservation of energy. Energy can neither be created or destroyed, but can be changed from one form to another. Now let's have a look at this in a question. So you got now here a diagram of X and Y, P and Q. You can see that there are different temperatures at play. So basically you just need to identify whether or not the pairs of objects shown are in thermal equilibrium, and if not, indicate the direction of flow of heat energy. If you'd like the opportunity to pause the video now, then do so. Okay, let's have a look at the answers. So you've got X and Y in thermal equilibrium, the same temperature. So you can see that's pretty straightforward. For P and Q, they are not the same temperature, so they are not in thermal equilibrium, and the heat energy will go from Q to P, so the 40 degrees to the 20 degrees. Okay, so it goes from the hotter object to the cooler object. Now let's have a look here at another question. We've got 3 blocks. So consider the following diagram. A, on the diagram, draw arrows to indicate the direction of energy flow between these blocks. B, what happens to these blocks if they are left to stand alone in time? And C, estimate the final temperature of the 3 blocks and explain how we got this, and if there's any assumptions that we've made. So if you'd like the opportunity now to pause the video. Okay, let's have a look here. So for A, you can see that the block on the top left at 80 degrees, the temperature will flow to the 50 and 25 degrees. Now the 50 degrees at the bottom will also flow to the 25 degrees, but not the 80. Okay, so you can see that with the green arrows there. Now remember, it always goes from the hotter object to the cooler object. Okay. Now B, what would happen if they were to stand alone with infinite time? Then you've got they will be at the same temperature. Now what is this temperature? Well, if you add those 3 temperatures up and consider the masses, then you're approximately going to get 51.67 degrees. Okay, so you need to take in consideration the temperatures and the masses, okay, and how many blocks there are. That's basically it. So this is the concept of thermal equilibrium. I've discussed the laws of thermodynamics. I've also explained in terms of when there's two bodies that are in thermal equilibrium and not in thermal equilibrium. So please continue watching my playlist. If you already haven't, subscribe. Any feedbacks, good feedback for me in the future for making my next set of videos for the Year 11 course, Module 4, and for Year 12. Thank you for your time.